Hello, seventh graders. Nice to see you again. Today we are going to be talking about Unit 6, and we are doing part 2 of the review packet. So if you want to stop and pause the video and get the review packet out for Module 6, Expressions and Equations, and then press play, and then we'll get started. Okay, I am looking for the correct module. Here we are. There we are. Okay. So we are doing problems number 12 through 22 today, and we are doing the even problems. So looking at our standards, this is our review pack. I'm going to put myself down here. Our standards today are, let me grab my little tool here. EE1, I can add, subtract, and expand linear expressions. And EE4, I can construct equations to solve problems. So that's what we've been working on, and you'll be ready for your test after completing this review packet. So let's get started. We left off from part 1 on number 12. So I'm going to scroll down. Hopefully you finished all of numbers 1 through 11, the ones we did not cover on the first part of the video. And let's find number 12. Here we are. So let's read number 12. It says, and I'm just going to make it a little smaller here so we got a little bit of room. A taxi driver charges $3.25 for the first mile of the trip and $1.25 for each mile after that. He charges a customer $17 for a ride. Write an equation that would help the customer find the distance she traveled in the taxi. So again, it's always a good idea to underline the numbers in a word problem. So we have $3.25 for the first mile. We have $1.25 for each mile after that. And we have $17 for the ride. And the question is asking us to write an equation, and we want to know the distance she traveled. So I'm going to come over here, and we are going to make an equation. So if we look at this, we have something called a flat fee, and we have a rate. So we have to decide which is which. We have got $3.25 to choose from and $1.25 to choose from. So which one of these do you think would be the rate? I can't hear you. Right, $1.25 would be the rate because it's saying $1.25 for each mile. So our rate is $1.25, and we need a variable to go with that. So I'm going to put this up here. Let M equal miles traveled. Always have to know what our variable stands for. So we're going to put $1.25 times the number of miles plus our flat fee for the first mile is going to be $3.25. Now, we're not quite done with our equation yet. We have to have something on the other side of the equals. Now, it gives us one more number in the problem. It's kind of hard to see with my lines underneath it, so I think I'll erase this one so we can see it better. And this number here is the total the customer paid. So this equation over here represents how to find the total based on however many miles she's driving in the taxi. So the total is going to be $17. So that is the answer to our equation. So let me write the answer here. $1.25M plus $3.25 equals $17. now it's telling us to solve using inverse operations. So to do that, we always have the goal, and if you remember from the last video, what is our goal when we're solving for variables? I'm going to put that in red so we see that. I'll put it right up here. The goal is to get the variable by, itself. And how do we do that? Using inverse operations. Like that. So we're going to leave that there so we remember. So we've got our little equation here. And now we're going to use inverse operations to get the variable m by itself. So we have a number of things we have to do here. You can see we want to get this $1.25 by itself, but we have this $3.25 on the wrong side of the equals. So we need to get this $3.25 over to that side using inverse operations. So to do that, I'm going to see if I have plus 325, the opposite of plus 325 or adding 325 is to subtract 325. So I'm going to minus $3.25. Whatever we do to one side of the equation, we always have to do to the other. So I'm also going to minus $3.25 on the other side. Now, if you notice something, I have a little bit of an error. See if you can tell what it is. Somewhere right around here. Can you tell what it is? If you've forgotten how to subtract with decimals, we have to line up the dot. Now there's no dot, there's no decimal with 17. But when there isn't a decimal, we can just assume it's after the number. We can add 2 zeros. That doesn't change the number, does it? $17 is still $17. It's $17 and no cents. Now, I think that gives me an urge to just play our song for a minute. It's been a little bit. I'm mainly playing this for Myriam because I know how much he loves the song. So let's see if I can get this song to play for us. Unless it disappeared on me. I think it did. Let's see. Well, maybe I'll get it later. In the meantime, oh, here it comes up. But I think it disappeared. Yep, see if I can get it. Rappin' mathematician. Okay, should come up. There it is. Here we go. It's got some numbers in the screen, but that's okay. Okay, I'm gonna move me a little bit. And there we go.
Now what in the world is that itty bitty dot? Yo, I just can't remember and it's making me distraught. I saw it in the price of the item I just bought. It's the decimal point. Yeah, now you're getting caught. When you add and subtract them, there must be a rule. So listen to my rhyme.
I have my baseball hat on.
Just line up
The dot and give it all you got. Just line up the dot and give it all you got.
And when you take the difference, in other words, subtraction, just use the same rule and bring on the action. Just
line up the dot and give it all you got. Just line up the dot and give it all you got.
So turn on.
All right, that's good. Now, let's go back to our review. So, we're going to go back over here and line up the dot. We did. So now we can subtract. So, I go here. I have my $1.25M. That's still there. We haven't done anything with that yet. Now we have a minus and a plus $3.25. That should end up giving us 0 because they cancel each other out. Equals, now to do this, I'm actually going to erase a little arrow for the moment, and I'm going to move this down one so we have a little bit more space to write. And when we're subtracting, we can't take a 5 from a 0, so we have to borrow. We can't borrow from the second 0, so we have to go all the way over to the 7 and make it a 6. And remember, when we have a couple zeros in a row, the end one becomes 10, and all the other ones, if there are more, which there are, become 9s. Not a very good 9, but kind of tell what it is. So now we have 10 minus 5. That's going to give us 5. And now we have 9 minus 2. That's going to give us 7. Back up a little, line this up, line up our dot. And then we have 6 minus 3. That's going to give us 3. And we have 1 minus nothing is going to give us 1. And I'm going to try to get that all lined back up. And it's positive because the 17 was positive. Okay, now I'm going to drop the 0 because I can, because any number plus 0 is just the number. So we have $1.25M equals $13.75. Now I'm not quite done yet. I have another operation to do. Remember, I'm using inverse operations. So if I look, I have $1.25 times M. So what is the opposite of times? Exactly. So division. So I am going to, put that there. I'm going to divide by $1.25. I'm going to put the line there so you know it's division. And I'm going to do the same thing to both sides of the equals. $1.25 on this side. And so $1.25 divided by $1.25 is going to give me just 1 M, don't forget the M is still there, equals, move the equals down a little, $13.75 divided by $1.25. Now I just want to remind us how to do long division. So I'm going to do this one using long division. I'm going to make a nice long division sign. And 3, so we have 1375, that's going to go on the inside. The top number is always on the inside, and I'm going to try to draw as neat as I can with my computer mouse. And on the outside is going to be $1.25. There we go. Now, whenever there's a decimal on the outside number, called the divisor. Think about that for a minute. You have to move the decimal so it's at the end of the number. So if I move 1 spot, 2 spots, I've moved the decimal away, correct? So I have to move the decimal over here 2 spots to the right. 1, 2. So my decimal is now going to be right there. So I can erase where it used to be. There we go. And if I need to, I can put the decimal right there. Now it's the same as saying, and let me just erase this and that. Oops, not that. Little dot I want to erase. There. So now it's the same as saying 125 divided by 1,375. Well, I can't take 125 into 1. Can't take 125 into 13. But I can take 125 into 137. Does anybody know how many times that would go in there? That would go in there exactly 1 time. And I'm going to put it right here because I went into 137. So my first number has to start over the 7. Now I multiply 125 times 1 is 125. And I'm just going to now erase the purple. There we go. And I'm going to subtract 137 minus 125 is going to be a 2. And 3 from 2 is 1. 1 from 1 is nothing. And then I'm going to bring down my 5. And I'll bet you everybody can figure out 125 goes into 125 how many times? Exactly 1. And then I multiply 125 times 1. That'll give me 125. And I subtract the 2 and I get 0. So the answer, go back to my problem over here. The answer to $13.75 divided by $1.25 is equal to 11. I can drop the 1 because 1 times any number is just the number. M is equal to 11. So now we can put our answer over here. What is the 11 representing? We go back up to here where we said let M equal miles traveled. We can understand that the woman traveled 11 miles in the taxi. Correct? Yeah, that's the answer. So go ahead and pause the video if you need to. Get your answers written down. Rewatch it if you need to. And then we're going to move on to number 14. Okay. Make some room here and scroll. There we go. Get a new page. Let's go down to number 14. Okay. Number 13 is going to be very similar to number 12. The difference is going to be there's a fraction in there. So number 14, we have to solve 43. I'll put it over here. 43 minus 37x equals 6. Now remember the goal. What is our goal? The goal is to get the variable on one side using inverse operations. Excellent. Okay, so I see that I've got, our little, oops, don't want that. I want my spotlight. You see that we've got a 43, it's a constant. We have a 37x, that's a rate. And we have a 6, that's a constant. We have to get the two constants on the same side together. So we could go either direction. We could move the 6 or we could move the 43. I'm going to move the 43 over to this side. How do I do that? I do that using inverse operations. Exactly. I know you're all saying that out in Cyberland. Okay, so I am going to minus 43 from both sides of the equals. And I'm going to draw my little line so we know that we are subtracting it. And then 43 minus 43 is going to be 0. We still have our minus 37x. It's going to equal, now we've got a positive 6 and a negative 43. So what does that mean? Well, we remember our integers unit. Negative 43 is like you owing me $43, but you have $6 in your pocket to pay me. So are you going to end up in the positive or the negative? Do you still owe me money? Of course. You owe me how much? Well, 43 minus $6 is going to be 42, 41, 40, 39, 38, 37. So you're still going to owe me $37. So let's put that in over here. Negative $37. Now we'll drop the 0 and we're just going to have negative 37x is equal to negative 37. We're not done yet. We still have to take care of getting x by itself, and we have this negative 37 times x right now. So we're going to use inverse operations and do the opposite of multiplication, which is division. So we are going to divide by the coefficient in front of the variable, which happens to be negative 37, the little division sign there. And we have to do the same thing to the other side. Whatever you do to one side, you need to do to the other. Keep our equation balanced. So now, negative 37 divided by negative 37 right here is going to be positive 1x. Don't forget there's that x there. And that equals negative 37 divided by negative 37, which is positive 1. Now we drop the 1 in front of the x. We have x equals 1. So that's our answer. So we're going to put that over here, x equals 1. And when you're doing these problems, it's a good idea to do them step by step because you don't want to miss any steps and make an error of some sort. So when you're first learning algebra, it's a really good idea to do one step at a time. Later, when you get really good, you can probably combine a couple of steps. So that's number 14. If you need to pause the video at this time, go ahead. I'm going to clear it, and then we're going to go on to number 16. Okay, number 16. Let's read the problem together, and I think I'm actually going to start underlining right away as we go. At a sale, Yvette paid $7.75 for an umbrella labeled 20% off. Write an equation, so we're going to write an equation that can be used to find the regular price R of the umbrella. And then we're going to solve to find the regular price. So then we're going to solve afterwards. So first we got to come up with an equation. Well, we have a couple of things in the problem. We have price paid, and we have a percent off. Now this one's actually a pretty tricky question. Got to remember our percent unit as well. So what was the price that Yvette paid? She paid $7.75. Percent off was 20%. Now, how do you change 20% into a decimal? Do you remember how to do that? Let's go back and think about that. So what you do is you move your decimal 2 to the left. So it starts after the number and you go 2 to the left, which would then mean that 20% is really equal to 0.20 or 0.2. You can always drop the 0 after a decimal. How does that even work out? Why is it that you can move the decimal 2 to the left? Well, if we think back, 20%, when we did our percent unit, is really 20 parts out of 100. Percent is always out of 100. So now if I were to divide 20 on the inside, divided by 100, it's supposed to be a 100, on the outside, I have to put a decimal here and add another 0. So put the decimal up here. How many 100s go into 200? Well, 2. I'm going to put the 2 over the second 0 because I went into the whole number. 2 times 100 is 200. And that 200 minus 200 is 0. So you see that 0.2, I'm going to get my little spotlight here, 0.2 is really the same as 0.2. So that's why we can move the decimal 2 to the left. Just wanted to show you that in case you had forgotten that from the percent unit. Now let's go on. Let's try to write our equation. Well, we know we have R, and that equals the regular price. And I'm going to make that a small r. Like I said, variables, I might have said this in a previous video, are usually small letters. So R is a regular price. So we know that we have to take the regular price of the item and subtract out the discount, right? And that will give us the price that she paid, $7.75. So we're doing good. We just have to figure out how to find this discount. What can we do to find the discount? Well, what do you do when you want to find 20% of a number? Don't you take the decimal equivalent, 0.2 or 0.20, times the regular price, right? Yeah. So we know the regular price is represented by the letter R. So 0.2 R represents, my spotlight here, 0.2 times the regular price. That is the discount. So I'm going to go back to where it says discount, and I'm going to say regular price R minus 0.2 R equals $7.75. So let's take a look at that. What does that say again? Regular price minus the percent off of the regular price equals what she paid for it. So now we can solve our equation. We got a little extra step in this equation because we have two R's that have to be combined before we can solve the equation. So remember how I said that when there's a variable with no number in front of it, we can assume the coefficient is 1. So I'm going to put that 1 back into there. And I'm going to move this up here so we got a little bit of room. And move that down 1. So now I have to take 1 R and I'm going to minus 0.2 R. Now, do you ever see what I have to do here? I have to line up the dot. So I think it's time to play that song again for a minute. Here we
On
go.
the TV, forget the radio station, because the itty bitty dot is a math sensation.
Line up.
To the right, and
Oh,
the number
wait,
becomes
sing line up
greater,
the dot
and the
already.
itty bitty dot needs no translator. Move it to the left, and the number gets smaller. Yes, the itty bitty dot is an academic scholar. So don't forget the rule, which needs no revision, because the itty bitty dot
Sing along with me.
big mission.
Line up the dot and give it all you got. Just line up the dot and give it all you got.
And thus this
All
concludes
right.
the decimal song.
I couldn't help myself. All right, back to the review. Okay, so we have to line up our dot. We've got a 1, so we got to line it up. So we got to put a dot there, a decimal, and a 0. Could put 2 zeros if we wanted, but doesn't matter. And now we subtract, and I'm doing it vertically because I had to line up the dots. So 1 minus 0.2. So we can't take 2 from 0. So we are going to cross off the 1, grab it here, and then make this a 10. 10 minus 2 is going to give us, 10 minus 2 is 0.8 R. And we lined up our 0.8. So now, and that equals $7.75. Next step is use inverse operations to get R by itself. We have a coefficient of 0.8 in front. So we're going to have to divide by 0.8. Very good. You guys got this. 0.8 and divide by 0.8 over there. And this is number, what number are we doing? We are doing number 16. Okay. So now, I'm going to put this here. And I'm going to put this here to show that we're dividing. So what is 0.8 divided by 0.8? That's just 1 R, right? Or just R. We'll drop the 1. Equals, now we have to do $7.75 divided by 0.8. So again, I'm going to use long division. I'm going to make a straighter line this time, like this. And I'm going to erase this and just erase all this so we got a little bit less stuff to look at one time. Put that there. So $7.75 goes on the inside because it's on the top of the fraction. And 0.8 goes on the outside. And remember, now we have to change my color here. Move my 0.8 because it's a decimal on the outside number. So if I move the decimal on the outside number, I have to move it once on the inside number. So now my decimal is now going to go right there, right there. And now I have 8 divided by 77.5. So how many 8s go into 77? 9 times 8, correct. I think I heard that out in Cyberland somewhere. 9 times 8 is 72, and I think I'm going to actually probably almost run out of room on the bottom here, but let's see. 77 minus 72 is going to give me 5, and then I'm going to bring down my 5. How many 8s go into 55? Well, 5 times 8 is 40, 6 times 8 is 48, 7 times 8 is 56. That's too high. Has to be a 6. 6 times 8 is 48. Let's see if I can squeeze it in here. 48 minus 55. 5 becomes a 4. 15 from 8 is 7. I'm talking about money here, so I have to go another place or 2 because I might have to round, right? So I'm going to bring down the 0. How many 8s go into 70? 8. And that's 64. And I am out of room, but 64 minus 70 is going to be 6. And then if I brought down another 0, I'd have 60. So I would end up with 8 times 7. So this number would end up being a 7. So now I can round. And I'm going to go back over here now. All of that was just to show long division for $7.75 divided by 0.8. That comes out to $9.60. And then we're going to round this 8 up because the 7 is bigger than 5 to 69. So what did I just find? I go back to my problem. First, let's put the equation in that we came up with. The equation was 0.8R is equal to $7.75. And the equation, solving it, came to R equals $9.69. But what is R? Go back up and see, what did we say R was? The regular price. So that means that Yvette's umbrella originally costed $9.69. Makes sense? That was a doozy. That was a tough one. So, okay, if you need to pause the video and get the information down, feel free to do so. I am going to share the notes with you. So after the video, you can download the notes, which will be in Google Classroom along with the video. Okay, clearing, going, gone. And let's move on to number 18. A little bit new page here. So this is number 18. So we'll rewrite it. 5z plus 8z plus 6 equals 42 minus 10. This one has a few extra steps. We do need to get the variable by itself, but we have a couple things to combine first. So if I look at, I have to combine like terms. I have a 5z and an 8z that have to be combined because they both have a z. So I can't combine them with any of the constants, however. So what is 5z plus 8z? Exactly, 13z. So now I have 13z plus 6 equals 42 minus 10. Now I have to get this 6 to the other side of the equation. So I'm going to subtract 6 from both sides. Minus 6 equals there. And before I do that, I'm just going to take these two right here and I'm going to combine them right away. So what is 42 minus 10? 32. So now it'll be a little easier. So minus 6. And now I can put my little line underneath. I like to line this up a little bit better. And now I have 13z plus 0, I want to underline that, equals, now I have 32 minus 6. What's 32 minus 6? 31, 30, 29, 28, 27, 26. Fingers work sometimes too. 26. Now I'm going to drop the 0 because I don't need to put the 0 there, equals 26. What is my step next? Exactly, division. What am I dividing by? Excellent, 13. I know you all said it out there, so I'm just going to know I have great faith in you all. 13, 26, they're both going to be divided by 13. 13 divided by 13 is 1z equals 26 divided by 13. That may not be obvious to you right away, but what's 13 times 2? 26. Now I'm going to drop the 1 with the z. So z is going to equal 2. So my answer then, to put over here on my paper, z is equal to 2. Now, if I doubted myself, and I said, I'm not sure if I got the right answer, I could take the 2, I'll just put it over here, and plug it back in for the z. And I should get a true statement out of that. So I could check that. So let's check that. So 5 times 2 plus 8 times 2 plus 6 should equal 42 minus 10. So always do multiplication and division before adding and subtracting. So 2 times 5 is 10, plus 2 times 8 is 16, plus the 6 should equal 41 minus 10. We figured that out before to be 42 minus 10. See, my mistake. Figured that out to be 32. And now 10 plus 16 is 26, plus 6 equals 32. 26 plus 6 is 32. 32 equals 32. The statement is true. So we did it right. So our z value is correct. Okay, if you need to pause the video, you can. I'm going to go on from here. We're going to scroll. Here are my drawings. And we're going to scroll down to number 20. 20 is similar, but this time they want the answer in a mixed number, a whole number and a fraction if anything's left. So we have 7b minus 8 equals 3b plus 42. And what do we do? Well, we have to get the constants together, and we have to get the variables together. How can we do that? Well, we have to use something called, come on, help me out here, inverse operations, the opposite. So I'll start with the constants. I like to start with constants. I have a minus 8, so to get rid of it from this side, I'm going to add an 8. Whatever I do to one side, I have to do to the other side. And I'm going to have to erase this one so that we can see it. So now I'm going to underline and underline. I hope you guys are having a good day or good night or whenever you're watching this. I hope you're staying away from crowds and that you are not going stir crazy. Okay, so now I still have my 7b, and now I have a -8 and a +8. So that becomes, obviously, 0, put the underline under there. So that's going to equal plus 0 equals, we still have our 3b, and we have this 42 plus 8. 42 plus 8 is 50, correct. Now to get the 3b to the other side. So I'm going to subtract 3b from both sides. Hopefully this is starting to really click and you're saying, I get this. This isn't so bad. Hopefully. A lot of confidence that you guys are a smart bunch. That you're doing just great. Okay. 7b minus 3b is 4b is left. I'm going to get rid of the underlining. Drop the 0 equals, well, 3b minus 3b is 0. So 0 plus what's left, the 50. Drop the 0, 4b equals 50. Not quite done. Inverse operations, divide. Divide by, I heard it, 4. Very good. So I'm going to divide both sides by the number 4. 4. And 4 divided by 4 is going to leave me with just 1b or b. And now we have 50 divided by 4. And that I'm going to have to do long division wise. So make our little house, so to speak. And what goes on the inside? Exactly, the 50. There we go. Just so you guys know, I don't really get an answer. I'm just talking to a camera. So anytime you can help at home by saying the answer out loud, great. 50 divided by 4. It's kind of a messy 4, but we can get it. 4 goes into 5 one time. 4 times 1 is 4. 5 minus 4 is 1. Bring down the 0. 4 goes into 10 twice. 2 times 4 is 8. 10 minus 8 is 2. Now, if I go back over to the problem, it says to reduce any fraction to lowest terms. So we want a fraction. So this 2, drawing tool back out, a different color. This 2 is going to come back up here and become the numerator of the fraction. And what's the denominator going to be? The 4. Correct. But we don't want to leave it as 2/4 because 2/4 can be reduced to what? What can you divide the top and the bottom by? 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. So the answer for B is 12 and 1/2. So let's put that in over here. B is equal to 12 and 1/2. Now, if you doubted that, you could check by putting 12 and 1/2 back in for B up in the original equation. You could take 12 and 1/2, plug it in here, and plug it in right here, and see if you get a true statement. If you do, you got the right answer. Okay, I think we have one more to go. So we're going to clear these. and scroll down to number 22. Now on 22, it's very similar to what we just did, but you notice there's one extra step before we can solve it. We have to use, and I think we talked about this on the last video, maybe even this one, but I think the last one for sure, the distributive property before we can do the solving for the variable. So let's type out 3 times x minus 11 equals 4x minus 15. So distributing the 3 times the x and the 3 times the negative 11. Doing that will give us 3x minus 33 equals the 4x minus 15. Now it becomes a regular problem for us that we can solve. Now we have to get the two constants together and the two variable coefficients together. So we would take 33 here and get it over here somehow. So we use inverse operations to do that. So we're going to add, because it's minus 33, 33 to one side and 33 to the other side. When I add 33 to both sides, I'm keeping the equation equal. And now I'm left with 3x plus 0 equals 4x. What's next? What is this minus 15 and this plus 33 going to give us? Well, isn't that the same as 33 positive minus 15? So I'm just going to rewrite it vertically. Sometimes you have to do that to get a picture in your mind of what's really going on. So 33 minus 15, the 3 will become a 2. The 3 on this one spot becomes a 13. 13 minus 5, 12, 11, 10, 9, 8 becomes an 8. And 2 minus 1 is 1. And because the 33 is positive, my 18 is going to be positive. So it's going to be 4x plus 18. Now I have to get the 4x to the side with the 3x. To do that, I'm going to use inverse operations and subtract, right, minus 4x to both sides. Minus 4x, we're going to drop the 0, equals minus 4x. We still have our plus 18 there. Our little underline there, and our underline there. And 3x minus 4x is going to give us negative 1x, or just negative x, equals the 4x and the minus 4x is going to give us 0x, or just 0, plus 18. Okay, we're going to drop the 0, so we have negative x equals 18. We don't want to leave it like that. Oops. So we are going to divide by, remember it's like imaginary 1, we're going to divide by negative 1 to both sides of the equals. And if you want, I could put this 1 back in just so you can see that. So negative 1 divided by negative 1 is going to give me just 1x, or x, equals 18 divided by negative 1 is negative 18. So that should be my answer. So let's go back here and put in our answer. X is equal to negative 18. If I doubted my answer, I could always check it. How? By putting the negative 18 in for any place in the equation that you see an X, and using our order of operations to solve to see if it's true. Okay. Now, the bonus question, I would like you all to try it. I'm going to give you a little bit of a hint for the bonus question. Let's read it first. Sammy, Ben, and Louis went to lunch. Ben's meal cost 45 cents less than Sammy's. Louis's meal cost twice as much as Ben's. If the bill came to $9.25, how much does each owe? And then it gives us a little hint. Let S equal Sammy's share. So we'll write that over here. S equals, well, let's do it this way. Sammy equals S. And Ben, what does Ben equal? Ben is 45 cents less than Sammy. So Sammy was S. So Ben is going to be minus 45 cents less. We'll put that in parentheses like this. And then finally, Louis. What does it say about Louis? Louis' meal cost twice as much as Ben's. So twice as much usually means timesing by 2, right? So 2 times S minus 0.45, that's Louis. And we have the total. The bill has come to $9.25. So we could add these three expressions together, set them all equal to $9.25, and solve for S. So I'm going to let you guys give that one a try, and if you want to email me and I'll give you the solution to that after you've given it a little bit of a try, that would be fine. I'm going to clear this. And now we're going to talk about our homework, and we'll be done for today. Your homework is going to be, I'm going to move this up to the top, to finish Module 6 review. So we have questions number 12 through 22. I have done all the evens, so you just have to do the odds, but review the evens and or review this video. So after this, I would like to get together on a live session and go over the odd problems from the whole review packet, the ones that you are doing on your own. If you have any questions that arise before them, feel free to email me at any time. I'm going to stop sharing, so I'm going to get big here in a minute. There we are. Okay, so I hope you have a good day or a good night, and we will be in touch again soon. Bye.